Nobody higher, everyone's got one. So every time I pick one today, there's going to be a response. Not just looking at each other awkwardly. Okay, here we go. Okay, just need one. All right, first one. We're going to be reading a lot of tables today, and I'm going to be asking probability from the table. All right, so take a look at this first one here. Find the probability. You choose a customer who has 2 pets. So read the table. Find how many customers have 2 pets. So here we go. First thing I need to know. How many customers have 2 pets? Here we go. 14. 33 customers have 2 pets, and I'll give you a second. Out of how many total customers? Out of 100. Just emphasizing this one last time, everyone. One last time. That's fine. 33 out of 100. 0.33, fully acceptable. So would 33%. Okay? Any version, percent, decimal, fraction, I'm all right with. Find the probability you have at least 3 pets. What's at least 3 then? 3 or more. Yep, 3 or more. So again, first question, how many customers have 3 or more? 18, how many have 3 or more? 27 out of how many customers again? 100. Okay, 3 or more. 3 and 4. No issues? Because what we're going into now is, now it just won't have one piece of information, it'll have 2 pieces. So take a look at this table here I provided you. This is where we're going to stay all day today. Not only did I break it up into male, female, but I also broke this up into how many males are going to college, not going to college. 2-way. I call this a 2-way table. All right, 2 different sets of data. Male, female, going to college, not going to college. What's the probability a person picked at random would be female and going to college? So read the table, female and going to college. How many females going to college? 1. How many females going to college? Oh, but I just, calm down. 13 females going to college out of a total of how many now? No. It says picking a random person. So out of 52. 13 out of 52. And you know how I roll, Lucas. I always like to reduce if I can. That's you, yes? Yeah, it's fine. There's not much there, so. 1/4. Stop now. Anything where the 13 or the 52 came from. All right? Would be female or someone going to college. Look at the difference here. In part A, I wanted female and going to college. Here, you could be female or you could be going to college. All right? And, woo, I got that or in between. From Friday, what's that mean? I'm probably going to do the probabilities. Add them together. Yep. That or usually tells me, hey, you're going to add those 2 probabilities together. So let's start with female from the table. College or not, doesn't matter. Probability you get a female, 18 from the table. 20, how many females? 22 out of 52. There's female, everybody. 22 females out of 52. Now, or somebody going to college, regardless of gender. All right, going to college. What do you got for me? 14? How many people are going to college according to this? 49. Out of? There we go. Too bad the answer is not 51 out of 52. Too bad. Anybody remember from Friday what I still have to look out for? And this is why we did part A. Go ahead there, Alex. Yeah. Aren't there females that are counted here and females going to college counted here? I can't count them twice. So you need to subtract out how many females are going to college, which we figured out in part A were what? Or you can figure, go look at the table again. How many females going to college? 13 out of 52. Then we end up with 38 out of 52, or also known as 19 out of 26. Stop. We're that minus 13 out of 52? You mind if I just use you for an example? Look, Brienne, female, all right, going to college. So didn't she just get counted in the 22 here and the 29 here? But she's only one person. I can't count her twice. So she's 1 out of the 13 here that I needed to subtract out. Cannot count the same person twice. All right? Yes? So you subtracted it out from each of them? Or just one? Okay. And it was still fine? Yeah, as long as you don't subtract them out of both of them, because then I'm taking Brienne totally out. Okay? Good? Good question. Okay, here you go. Now the only difference is I didn't put the totals with it. Sorry. All right, I didn't put the totals on this live band DJ male-female deal. Probability that a randomly selected student wanted to have a DJ at prom. All right, so how many students want a DJ at prom? 4? What do you got for me? 237. Where'd you get it from so your classmates know? Yep, he added the 102 plus the 135. All the students that wanted a DJ. Out of Ethan, how many total students were surveyed here? 435. Yep. And I believe that reduces down. So when you get a second, let me know what it reduces down to. Yep, 79 over 145. Good deal. Both male and wanted to have a live band. Both male and wanted to have a live band at prom. So both have to happen here. Here you go, 5. How many are male and want a band? 103 right here. Out of how many people here? 435. And I do not believe that breaks down at all. No. All right, ready to get nuts? Probability you select a student that's female or wants a DJ. Don't mistake that for female who wants a DJ. That's probability of female, probability of a DJ. And it got an or there, so what am I doing? Adding the two probabilities. All right, so let's start with probability you get a female. Probability from the chart, you get a female out. Here we go, probability. 15, what do you got for me? Out of, you got it. Wanted a DJ. Wanted a DJ. A student wanted a DJ. 2, probability a student wanted a DJ. Out of 435. Even if you stop here and have a brain freeze, you're going to get a number bigger than 435 on top. And that's a problem. Can't have a probability bigger than 1, right? What did we forget? Did we count some people twice? We counted the females, and we counted the DJ who wants a DJ. I believe there's females who want a DJ. So what should I be subtracting out now? What should I be subtracting out from both of those? Here we go. 17, what do you want me to subtract out? 135 females who wanted a DJ. And we should be left with 332. students that are female or want a DJ? You guys doing all right? All right. And we got this last one. What's why did you put it last? Usually the last ones are the toughest, right? What's the probability a randomly selected male wanted to have a DJ perform at prom? All right, big deal, right? How many males want a DJ? One. How many males want a DJ? Out of? Whoa, man! I thought I was going to get him. Why not 435? Read the problem, right? What's it say? What's the probability of randomly selected male? Look at the wording through A, B, and C. What were you doing? A randomly selected student. So that's why it was out of 435. Now it's going to be out of males. So 102 out of. Does that reduce? How about you check? Okay, are we good? Slight, Lucas, after that performance, slightly moving up my mountain of respect. All right. Very small step, though. Very small. Okay, but you had nowhere to go but up, so. All right. Are we okay? How that changed into 205? All right. Now, wouldn't it be great if instead of the numbers they gave me, they automatically already had the probabilities in there for me? All right, like 103 out of 435, 102 out of 435, instead of me having to calculate it all. And the answer is yes, there are tables that do that. Take a look. All right, take a look here. We're at Eagle High School. Here's the probability you'll be in 9th grade. Now, hey, that doesn't mean 0.29 kids, right? Come on, have some self-respect. Not 0.29 kids. That's a probability you're in 9th grade, 10th grade, 11th grade, 12th grade. All right. First thing I need to do is make sure this is legit. Make sure these tables are legit. Make sure they're valid. How do I show it's valid? 2 ways. Make sure every probability. Probabilities can't be bigger than what? Can't be bigger than 1. Make sure all the probabilities are not bigger than 1. All right. 0.29, 0.26, 0.25, 0.2. We're good. All right, so all probabilities less than 1. If you see a 1.20 there, that's not a valid table. That table is not legit. Second thing you guys got to check for, all the probabilities they give you better add up to what? 1, 100%, right? All probabilities should add up to 1. So let's check right now with me. 0.29 plus 0.26 plus 0.25 plus 0.2. What do we end up with? Adds up to 1, yep. So this is a legit, valid table. All the probabilities less than 1, and they all add up to 1. Okay, let's answer a question now. You choose a student at random. What's the probability he or she is in grade 11 or 12? All right, so here we go. Let's not make this tough on us. 7, ready? What's the probability they're in grade 11? Just grade 11. Don't get ahead of me. Grade 11. 0.25. Again, that's not how many students. So, hey, notice I'm not putting over something. That is the probability right there. 0.25. Plus, and then what about in 12th grade? 0.2. I don't need to worry about, what if they're in both? I don't need to worry about that, right? 11th and 12th, that would be kind of, that's an odd situation. I guess what, the kids who graduate early, I don't know, are they considered seniors or not? Okay, great talk. That's why I'm going to keep calling on people. 0.45. Vinny, favorite Thanksgiving side dish? Okay. What do you put butter on them? Bacon or chives? I don't know what you kids put nowadays. Sour cream? I don't know. Okay. Are you the type of person that separates your food, or you just pile it all in and mix it all together as you're putting it on? So it's okay if the green beans are touching your famous mashed potatoes. Okay. Anybody have to have them completely separated? No? Okay. I just asked, my wife does, and I think it's the weirdest thing ever. And I'm going to end up mixing something together sooner or later, but whatever. That's how she rolls. All right, here you go. Now you fill in your own table. Fill it in with the correct numbers for me. Oh, Joanne. Sent out a survey to freshmen and sophomores if they're attending the spring fling. Nice. Lucas, huh? Froshies, huh? Softs. All right. Yep. Okay. Yep. Here you go. All right. So here we go. I have to always pick on somebody about it. All right. As long as we're not headed down Kenwood to the middle school, we're all right, right? Yeah. Okay. Or God forbid, across the street, we're good. All right. Free candy, kids. All right. Here we go. What? Too harsh, everyone? Too harsh? I only pick on you because I know you can take it, Lucas. All right. Here we go. 66 freshmen responded. Where's that 66 going to go in my table? Total freshmen. Yep. 66. 32 saying they're going to attend. So 32 freshmen saying they're going to attend. And of the 84 sophomores, so 84 sophomores responded, 46 said they would attend. 4 values, 5 are missing. Who cares? You can find them. All right, go ahead. Find those 5 missing values. Okay, what's my missing values here? Let's go. 14, let's roll. Wherever you want to start. 34, yep. Yep. How many total are attending?
78 total.
Yep, not attending?
And then 72.
And then how many did they survey?
150.
There we go. There you go. Everyone okay? Okay, how many people responded to the survey? We can just call this one out here. I don't need to call on people. How many people responded to the survey? 150. Again, this is not a probability question. I didn't ask for the probability, just the number of people. How many students were surveyed are attending the dance? 78. And then how many surveyed sophomores are not attending? 38. There we go. Okay. This is called the two-way frequency table. Now let's change this frequency table and actually put the probability a freshman is attending. That's what I want to do next. All right. So if you go to the next table, it's not called a frequency table. It's called a relative frequency table, which now I don't want to know the number of people. I want to know the probability. So what's the probability a freshman is attending? That's what I'm going to put here. And we're going to round it to the nearest 1,000. So I'll do the first one with you and then let you go on your own. How many freshmen were attending? 32 out of what? 6. Well, this is out of everybody now. So 32 out of 150, yes? So I go to the calculator. 32 out of 150 gives me a probability of 0.1 rounded to the nearest thousandth. 0.213. So that is what's going to go in my table, 0.213. So I'll give you about another minute, flip back and forth, find me the probabilities of sophomore, freshman attending, not attending, and the totals. Take a look at your table. Make sure all the probabilities are less than 1, and hopefully all your probabilities added up to 1. So you know your table's valid. All right. Okay, I just need somebody to give me all the probabilities. If somebody has an issue with one of them, let me know. Here you go. 1, Lucas, ready to go? Okay, where do you want to start? Let's start freshman not attending. 2, 2. Okay, total? Just 0.44. This adds up to 9. 0.44? Is that what it? Okay. 0.4, okay, 0.440. How about that? Okay, keep going. Go ahead. Sophomore is attending. What is it? 306? No? And what do I have here? 0.227? 307. Here we go. Not attending sophomore. 2.5. Adds up to 1. Okay, here we go. Total attending. What? What? Not attending? I don't know what's going on. Everyone all right? This kid, I'll tell you. All right, last one. That's what I'm working with here. 6th period. There's a lot to read there. Wow. All right, let's just get right to it. Based on the survey, probability a randomly selected student at this high school having asthma was 0.193. Where can I plug that into my table? Again, that is the probability a student at the high school has asthma. Where's that 0.193 going to go then, if they have asthma? Where on my table here? Here we go. 1 again. Sorry, Lucas. Total for, because I got a lot of totals up here. Yep, so right here, 0.193. Everybody stop right there. Stop before, I don't want to get to the 0.421 yet. Let's go right to problem A. What other probability can you find now? Knowing that that's 0.193 right here, total that have asthma, what other value up here can you find? Forget about the 0.421. We don't know about that yet. What other one can you find? 9, what other one can I find up here? Don't have asthma, yep. So students that don't have asthma, I can just subtract. A-S-T-H-A. That's a good spelling bee word, huh? Okay, let's go to the 0.421 now. That is at least one member of his or her student. I was also asked that at least one member of the household who smoked was reported that 0.421. Where's that going? 16. Where should I put that 0.421? Total, yep. 0.421. Now, knowing that, again, you don't know the 0.193. Just knowing the 0.421, what other probability can you locate up here? Here you go. 4, what other probability? The what? So no smokers in the house. Yep, total no smokers in the house. And then let's finish this off strong. In addition to those two I just filled in, now we know that if a student selected at least one household member smokes, has asthma. So 0.120, ready? Has asthma, and at least one household member who smokes. Boom, right here. So 0.120? Now, given all three, what probabilities can you find? And again, we already found out, don't tell me again, we don't need that one and we don't need that one because we've already found those out. Now, given those three, which values can I find? And there's two answers I want from two people, two answers. Here we go, 10. What's one probability I can find now? Okay, student does not have asthma, at least one member smokes. Okay, so student has asthma, and at least one member smokes. And the final probability we can have, which is, let's see, we just found, what did we just find? Student has asthma. Oh, wait, hold on, I wrote that incorrectly, didn't I? Who just gave me that answer? Reagan, say it again. Which one did you find? Yep, okay. I just didn't write it down correctly. We found that one right there. So student, there we go, does not have asthma. And at least one member smokes. Looks like a fourth grader's writing this. I don't care, no shame. And what's the other one I can find then? Let's finish this off so we can get out of here. 4, what's the other one I can find? Okay, student has asthma, no smokers in the house. Yep. All right, and then you guys can get going right on the on the assignment. Get going right up to the bell.